Hi, my name is Callie Wilson, and this is my Physics 2212 Lab 1 charge tape. My introduction is in this lab, we charged two pieces of tape by putting them on top of each other and then ripping them off one another. And then the purpose of this lab is to observe the interactions between two pieces of charged tape and then determine the amount of excess charge on each piece. This experiment will have a physical experimental model of what was performed in lab, and then also a computational model made with GlowScript. A preview of my results are that they showed that the charge tape would separate about 1 inch when they had the same charge, and that they both held a positive charge when charged. And the initial conditions, the tape mass was 2 times 10 to the negative fourth kilograms. The system was the suspended piece of tape, and our surroundings was literally just everything else. More introductory stuff. What we'll be using is Newton's second law, Coulomb's law, and gravitational force. All of these equations next to them correspond to what they're labeled as. So that is what we use for our calculations. And then here's my computational model of GlowScript and the GlowScript that I wrote out. You can see the variables of tape mass, length, width, distance that I could all plug into my gravitational force and my Coulomb's law so that I could properly get the charge I'm looking for. Here are my results from the GlowScript computational model. The procedure for the physical experimental experiment we did ourselves was that we created charges on YouTube by placing a base piece of tape on the table and placing another piece of tape on top of it and quickly ripping it off. This induced a charge on, and then we also induced a charge on a pin by rubbing it to human hair. And then we placed a charged pin hanging beside or next to a U-tube that was hanging to determine the sign of the charge. Then we also suspended a piece of U-tape between two supports and placed another U-tape beneath the suspended one. And then we measured the final separation of the two tapes. Just all trying to figure out the charges of the tapes. Here are the calculations I did based off the physical trial, and this is the charges we got simply using, once again, gravitational force equation and Coulomb's law equation. There's also a free body diagram here, and we determined with this, at least what we got here, was that the charge magnitude was within a reasonable range, um, whether it be in coulombs or electrons, which are both of the two answers that are highlighted. And so some of the like assumptions we made that like might affect the results. We didn't account for air resistance and friction. Those are negligible. And then we determined the longer piece of tape is what we're calling the point charge in this scenario. And then each piece of tape we assumed had an equal amount of evenly distributed charge, which all this isn't necessarily true. And there's a few sources of error that we could have taken into account, as always, human error, loss of charge to the surroundings, and also measurements such as like distance and length being off by slight amounts. But in the end, both results determined that they are positive, but the computational and physical models, when it came down to calculations, some things were just off. And I think that's when it comes to the numbers, besides just whether it being positive or negative. And I think that is part of why, just like assumptions we had made in human error. And then to answer the discussion questions, what if electrons and protons had inverse charges? The results would remain the same, but as both pieces of tape would be negatively charged, they would repel since the charges, like charges, repel. They would still be attracted to positively charged items like the pin, which are now positive since the charges are inverse. And then why is it important to handle the tape as little as possible? This is important because initiating contact with charged objects begins to neutralize those objects as they try to gain back electrons that have been lost. So that is all. Thank you.